Now see a mirror formula. So we are going to derive mirror formula for concave mirror as well as for convex mirror. So let us take first one is the concave mirror. Suppose you have taken concave mirror like this, and this is the principal axis. This point I am taking as pole of the mirror. Somewhere here is this is F, and here I am taking roughly that point is C, center of curvature. Distance between C and F and P are equal. And now suppose if you are placing somewhere object is over here, like object is suppose A and B. I am taking two rays from this object to top, one is parallel to principal axis and coming to this point after reflection. One ray I am taking passing through the center of curvature. After reflection it will retrace the path because it is a normal incidence, that means angle of incidence is 0 at this point. So these two reflected rays are intersecting at this point. So image is obtained over here, that is A dash and B dash. So we have taken here the object here and image is obtained here between the center and focus of this. This point we can take as M here. So this is one is L. Now first we can take triangle ABC and A dash B dash C. So we can write triangle ABC is similar to triangle A dash B dash C. Because these angles are of 90 degree, these are vertically opposite angles, so these two triangles are similar. Now we can write if the triangles are similar, so obviously their sides are in the ratio. So we can write here AB upon A dash B dash is equal to BC upon B dash C. This we can write as the first equation. Similarly, we can take the triangle LMF similar to triangle A dash B dash F. Again here these two vertically opposite, this one and this one is 90. So we can write LM upon A dash B dash is equal to here MF upon B dash F. But we know LM is equal to AB because the distance between two parallel lines are equal. So we can write AB upon A dash B dash is equal to MF upon B dash F. This I have taken as equation 2. Now by taking equation 1 and 2, we can write, say these to the left hand side are equal in both the cases. So we can write here BC upon B dash C is equal to MF upon B dash F. This is from equation 1 and 2. So now we will solve these two things here. We know here the BC. What is BC here? BC is this much. No significance of this. So BC can be written here PB minus PC. This is in place of BC. B dash C can be written, this is the B dash C, also can be written PC minus PB dash is equal to MF, that is a focal length. So we can write MF is equal to here, we can write PF because M and P are very close to each other because of the small aperture, and B dash F can be written PB dash minus PF. Now see, PB and PC and PB dash, all these things have some values here or some significance. So we can write PB is equal to, that is the distance between the pole and object, that can be written minus U because that is a negative opposite to the incident ray, and you know the PB can be written minus U, PC can be written minus R, and here PF can be written minus F. So these are here the the symbols used here, and PB dash can be written minus V. Everything is minus because everything is just left to the pole. So, now all these values are put over here in this equation. So, when we put all these values here, we will be getting this is minus u minus r upon minus r minus v is equal to minus f upon minus v minus minus f. That can be written minus u plus 2f, because r is equal to twice of f, upon minus twice of f plus v is equal to minus f upon minus v plus f. So, we can go for this one further solving of this, and we can write this equation here again. We just cross multiply here. When you cross multiply, you will be getting this one minus u, this we can written ub, and minus uf, this is here minus 2fv, and plus 2f square is equal to, and this will be multiplied to this one. So, that can be written 2f square minus fv. After multiplication, you are getting this equation. Now, you solve it. So, this 2f square will get cancelled. You have got here ub minus uf is equal to minus fv, and this one it will be going here, that is only fv. We will be dividing by uvf both the sides. When you divide by uvf, you will be getting 1 upon f minus 1 upon v is equal to 1 upon u, or you can write 1 upon f is equal to 1 upon v plus 1 upon u. So, this is actually here known as mirror formula. So, this formula 1 upon f is equal to 1 upon v plus 1 upon u is known as mirror formula, where u is actually taken as object distance, that is the distance between the pole and the object, and v is the image distance, that is the distance between the pole and the image, and f is the focal length of the mirror.